This question is related to work, energy, and power. The student set up the apparatus as shown. So you can see a trolley is there at a certain height h. When it rolled down, it moved downward and it moved a distance d. So here what happened? There is a conservation of energy. First, it will have a gravitational potential energy. Then it will have kinetic energy, and that kinetic energy is used to do work done against the friction. So it rolled down on a horizontal surface. So in the question, when released from a height h, a trolley ran down the slope and then continued to move horizontally. On the horizontal part of a track, the friction F is there, brought the trolley to the rest after a short distance d. The trolley has a mass m and the student measured the distance d as a range of height, like he's changing the height. So the distance is also changing. If a student roll down a trolley from a shorter height, then the distance move is small. But when it roll down from a greater height, it will move a greater distance. We have to drive an expression for a gradient of a graph in terms of f, m, and g. Look, remember what is a gradient? Gradient is always the quantity on y-axis divided by quantity on x-axis. That is the gradient. So what is there on the y-axis? On y-axis we have d. And what is on x-axis? We have x. So basically we want a ratio between d over h. So how we can work out the ratio between d over h? So first it will have a potential energy. Its potential energy change to kinetic, and then kinetic is used to work done against the friction. So in short, I can say the potential energy here will be equal to kinetic energy before it come down, like just before it reaches a horizontal surface, and then that kinetic energy is used to work done against the friction. So we can say the kinetic energy or the potential energy is equals to kinetic energy, or kinetic energy is equals to, so potential energy is equals to kinetic energy, or kinetic energy is equals to work done against the friction. So we can equate the potential energy with the work done. We can say potential energy is equals to work, and potential energy is given by formula mgh. And what about work? Work is a product of force and distance. So because we want a gradient, gradient is d over h, because a gradient is always a quantity on y-axis divided by quantity on x-axis. So we want d over h. So h is multiplied, other side it will be divided, and f is multiplied here with d, other side will be divided. So you can see d over h is equals to mg over h. So the expression here, that d over h, the gradient, will be equal to mg divided by f. So this is the second part of the question. As the trolley, in the second experiment, an identical trolley B was placed at rest from the at the bottom, and when a trolley A was released, when a trolley A was released as before, it rolled down and it collided with the trolley B. After the collision, the two trolleys join together and move off to the right with a velocity v. So basically what happened, the two objects stick together, identical trolleys two, and they stick together and move with a velocity v. The student predicted that provided the friction was ignored, like if we ignore the friction, then v is equals to under root g h divided by 2. And you have to assess whether the student was correct. So you can show in terms of formulas only. So how we can represent first part, because when two objects are colliding with each other, we can use the conservation of the momentum. So example, when this trolley rolled down before it collide with B, example, it's because at this point, the trolley A, example, it is having a velocity u, and trolley B is stationary in the beginning. So this is having velocity u and trolley B is stationary. But once A and B collide with each other, After the collision, both trolleys will move, the two trolleys will stick together and move with the same velocity v. So final velocity, so if I'm saying this is m2, this one is m1, m1 here. So what we have to do first, we have to find the initial velocity. We will use the conservation of momentum here. The momentum before collision will be equal to momentum after collision. And then we'll substitute the value of a u by using the concept that the potential energy for A converted into kinetic energy. So first we'll find the value of u, because if there is no loss of energy, the potential energy at the maximum height, loss in potential is equals to gain in kinetic. So potential energy, if I'm saying, even instead of saying m1 and m2, I can say m both of them. Reason for that, as they mentioned, they're identical trolleys, so they will have the same mass. So I can say this is also m, this one is m as well. So that does not make difference as the two trolleys are identical. So mgh is equals to loss in potential is equals to gain in kinetic, which is half mv square, or I can also say 1/2 mv square. But v is a speed, so we are saying the speed before at the bottom for a will be u, so it will be mv square, or we can say mu square because the speed is u. When we simplify, m will cancel with m, so gh into 2 is equals to u square, or I can say under root 2gh is equals to u. So the initial velocity of trolley A before it collide with trolley B, that is given by under root 2gh. Now we will use the conservation of the momentum. The total momentum before collision is equals to total momentum after collision. So momentum conservation, so momentum before will be equal to total momentum after. So momentum before, that is m, this the mass of object 1 multiplied by speed, so that is under root 2gh, plus the mass is m, but because the speed is 0, so this will be 0. Then the second object, the mass is m and the speed is v. Then it's also a mass is m and the speed is v. So we can say this will be equal to m under root 2gh is equals to mv plus mv. So that is equals to 2 mv. M is common both sides, so we can cancel m with m. So when we simplify this, it will be under root 2gh is equals to 2v. 2 is multiplied, other side will be divided. So under root 2gh divided by 2 is equals to v. And under root 2 divided by 2 is, when we simplify, it will be, because it is divided, so it will be gh divided by under root 2. So you can see the final speed at which the two trolleys will move together, that is given by expression under root gh divided by 2.